Hi. In this video, we are going to look at some more problems on sets. We'll continue our series of videos on set theory and problem solving. So let's look at this question first. Question 1 says, suppose S is a subset of 1, 2, 3 till 50, this set, and the sum of squares of any two elements of S is not divisible by 7. We have to find the maximum number of elements of this S subset, right? So let's think about how we go about this problem. S is supposed to be a subset of this set from 1 to 50, and you have to count how many possible elements you can put in the set S, subject to the condition that any two elements of S, the sum of their squares should not be divisible by 7, right? So let's think, if X belongs to S, then X can obviously have these possible residues with 7. So X can be basically 0 or plus minus 1, plus minus 2, plus minus 3 mod 7, right? So basically, what is the meaning of this? That when you divide X by 7, you can have these remainders 0, 1, 2, 3, minus 1, minus 2, minus 3. Minus 1 basically corresponds to 6 mod 7, minus 2 is 5 mod 7, and minus 3 is 4 mod 7. So this covers all the possible residues or remainders that we get when we divide X by 7, right? Now, if you think about it, what is X square? X square will correspond to 0 plus, there will be no minus, 0 plus 1 plus 4 and plus 2 mod 7, right? So if you square this X number, you can get these remainders when you divide by 7, 0, 1, 4 and 2, right? So what we need to ensure is that if X and Y belong to S, your X square plus Y square should not be 0 mod 7, right? Correct. Two elements, if you take X and Y belonging to the set subset S, then the sum of their squares should not be divisible by 7, right? So obviously, here you can see if you pick X and Y from any of these groups, what will happen? None of these squares, and you add them up, X square plus Y square, you can get basically 0 plus 1 or 0 plus 4 or 0 plus 2 or 1 plus 4, 1 plus 2 or 4 plus 2. But in none of these cases, you're getting 0 mod 7, right? You're getting 1 mod 7, 4 mod 7, 2, 5, 3, 6. So you can pick X and Y from any of these numbers as long as you are basically able to see that X square plus Y square is not becoming 0 mod 7, right? So we are basically saying that X and Y can be any two numbers not divisible by 7, right? Not divisible by 7. So how many numbers are there which are not divisible by 7? You can basically have 42 numbers, right? I think you can have 43 numbers, because 7 into 1 is 7 and 7 into 7 is 49. We will exclude all of these divisible by 7 numbers. So basically what I'm saying is, if you construct a set S which has 1, 2, 3, 6, and then you skip 7, you get 8, 9, 10, 13, and then you skip 14, and 15, so on, 41, 43, and then you go on to 48, and then you skip 49 and you write 50, right? This set that I have written right now consists of 43 numbers. What are these 43 numbers? These 43 numbers are the numbers which exclude the numbers divisible by 7, right? So the overall set, let's call it A, was 1, 2, 3 till 50. And now we are constructing a new set S, which has 1, 2, 3, 6, skip 7, 8, and so on, 48, skip 49, and then 50. So these are 43 numbers such that none of them is divisible by 7. So obviously, why have we picked these numbers? Because they belong to X is such that they belong to either 0, 1, plus minus 1, plus minus 2, and plus minus 3 mod 7. And obviously their squares are 0, 1, 4, and 2 mod 7. All of these numbers, the squares will belong to these 4 residue classes. And you can pick any 2 of them and they don't add up to a number divisible by 7, right? But this is not the answer. Right now, we might guess that S is 43. The maximum number of elements is 43. But what we can do is we can add one number to S, which is divisible by 7. Which is divisible by 7. Why? Because if you just add one number to S, it still doesn't make the sum of squares of 2 separate elements from here divisible by 7. So you can say 1, 2, 3, you can say 6 and 7. You can put 7 inside and write the same set. You will never be able to take 2 numbers from this set and add their squares and get a divisible by 7 situation. So we can add one number to S, which is divisible by 7. And how many choices do we have? 7, we have 14, and so on till 49. So one out of these 7 we can add. So the total number of S star will become 44, right? S star will have 44 elements. Why am I putting S star? Because it is an augmented S set, right? We are adding one more element to the S set, and that one element is a number that is divisible by 7. So it could be anyone between 7 to 49. Right? 7, 14, 21, 28, 35, 42, 49. Any one of them you can add to this set, and this still follows the conditions of the problem. So basically, we are saying the total number of elements in S, total number of numbers in S star is 50 minus 7 plus 1, which is 44. And if you take these 44 element subset, you will ensure that you satisfy the conditions of the problem, which says that take any 2 numbers from the subset and square them and add them, and they will still not be divisible by 7. You cannot pick 2 divisible numbers because then you will fail the condition of the problem. So we will say that the mod of S should be less than or equal to 44. That is our answer to this problem. Think about it yourself. If you're not getting it, please revisit the previous slides. Pause the video, go back and think about it. You should get it. It was a pretty simple problem. You just have to understand the condition very well. Okay. Let's go on to the next one. Question 2 says this. Let A be a set consisting of positive integers. Whose smallest element is 1, and largest element is 100. Largest element is 100, right? Now, the property that we have to worry about here is this. Apart from 1, every element of A is the sum of two other elements not necessarily distinct of A. We have to find minimum value of mod A, which is basically find the minimum number of elements that the set A can have, right? Now, this is a slightly tricky question. Think about it. A is a set like this. You can start with 1. You have A1, A2, and let's say we have AN, and then last element is 100, right? So we are saying that there are n elements apart from 1 and 100. 1 is the first element and 100 is the largest element, right? Now what the question says, apart from 1, other than 1, every element of A is the sum of 2 other elements, not necessarily distinct of A. So A1 should be the sum of 2 other elements, not necessarily distinct, right? Now, what I will do first is I will say that when I write this set, I have written it in increasing order like this. Obviously, no matter how you select the integers, you can always arrange them in an increasing order. We are going to assume that this is my increasing order. We are assuming right now that A1 is the smallest, A2 is the largest. This we can assume without any loss of generality. No matter what elements we put here, we are arranging them in increasing order, and this is the sequence, right? Now, we have to find the minimum possible number of elements in the set A. So think about it. How many elements can you fit in this set, right? So you should realize that since A1 is the next highest number, A1 should be equal to 1 plus 1. Why should A1 be equal to 1 plus 1? Because A1 has to be the sum of 2 other elements of A. But what is the other element of A smaller than A1? The other element is only 1. And you can repeat the 2 elements that you add up, right? So A1 has to be 1 plus 1. Because otherwise it cannot be obviously, A1 cannot be A2 plus 1. Because A1 is less than A2, right? So A1 has to be 1 plus 1. So A1 must be 2, right? Correct? We can similarly think about other elements, but for A2, if you start thinking like that, you could have 2 choices. It could be 1 plus 2, or it could be 2 plus 1, or it could be 2 plus 2. 1 plus 2 or 2 plus 2, right? So we don't know for sure what A2 will be right now, but we know for sure that A1 has to be 2, right? Now what I will say is I will assume that we can fit, let's say, 6 numbers here. I'm going to guess that, let's say we are fixing 6 numbers here, and we see if it is possible or not, right? I will show you on the next screen. So let's say the set A is like this: 1, A1, A2, AN, and 100. And we know that 1 is less than A1 is less than A2, less than AN, less than 100. We already know that A1 is equal to 1 plus 1 equal to 2, right? Now, what I'm saying is if N is equal to 6, so basically the total number of elements of the A set becomes 8, right? Because 6 here and 1 and 100 are already part of A, right? If N is equal to 6, we can say that A2 should be less than or equal to 2 plus 2 equal to 4, right? A2 is less than equal to 2 plus 2 because what were the options for A2? Think about it. A2 could have been A1 plus 1, which is 2 plus 1, 3, or A2 could be A1 plus A1, which is 4, right? So A2 has to be less than equal to 4. Similarly, A3 has to be less than equal to 4 plus 4 equal to 8, right? A3 has to be less than equal to 4 plus 4, 8, because otherwise it could be A2 plus A1, which is obviously less than 8, right? Similarly, A4 has to be less than 8 plus 8, which is 16, right? And A5 has to be less than equal to 16 plus 16, which is 32. And similarly, A6 has to be less than equal to 32 plus 32, 64, right? Correct. Now, since A5 is less than equal to 32 and A6 is less than equal to 64, we are getting that A5 plus A6 is less than equal to 96, right? Now, A5 plus A6 is less than equal to 96. Then the next number is 100. How will 100 be the sum of A5 plus A6? It cannot be, right? So that means what we are getting is 100 cannot be the sum of the previous 2 numbers, A5 plus A6. Therefore, 100 must be then 2 times A6. If 100 cannot be A5 plus A6, it obviously cannot be A5 plus A4 or A6 plus A4, anything lower than this, right? Because A5 plus A6 itself has an upper bound of 96, right? So 100 then must be twice of A6, which implies that A6 must be 50, right? A6 must be 50. That is what we are getting. If we take n as 6, right? I hope you have followed the argument so far. We have to create each number to be the sum of any two previous numbers, right? And it can be a repeated situation. So we are getting inequalities like this for each of these A2 and A3 and A4 and A6. And we realize that A5 plus A6 is less than or equal to 96. So 100 cannot be the sum of A5 plus A6. So 100 must be 2 times A6, which means A6 must be 50. And now if A6 is 50, let's think about what is A4 plus A5. A4 plus A5 must be less than 16 plus 32, which is equal to 48. So that means A6 cannot be equal to A4 plus A5. So that means A6 must be equal to twice of A5. And that means A5 must be equal to 25, right? A5 must be equal to 25. Now, if you do this argument one more time, you see A3 plus A4 is less than equal to A3 is less than equal to 8 and A4 is less than equal to 16. So 8 plus 16, 24. So that means A3 plus A4 cannot be equal to A5. And that means A5 should be equal to twice of A4. But we have already gotten A5 as 25, which is an odd number. So 25 is equal to twice of A4 we are getting, which is a contradiction. Odd cannot be equal to even, right? So basically we are saying that we are getting a contradiction for n is equal to 6. If you follow the rules of the problem and you take 6 elements in between 1 and 100, what we are ending up with is a contradiction where A5 we are getting 25 and from the other side we are getting it as an even number. So that means our assumption is wrong that n cannot be 6, right? I want you to try and show similar contradictions for n is equal to 5 and so on. You will be able to show similar contradictions for n less than equal to 5. And now what I will do for you, I will show you a case where n is equal to 7 fits the condition. So n is equal to 7 will fit the conditions of the problem, which will mean the set looks like this: 1, A1, A2, A7, and then 100. And I will show you an example of a sequence of numbers which will fit this. So it will be 1, 2, 3, 5, 10, 20, 25, 50, and 100. This is my A1, this is my A7. And notice that A7 is 50, so A7 plus A7 is 100. And 25 into 2, so 25 plus 25. A7 is twice of A6. And this is A5, A5 plus A3. This is A2, A3, A4. A5 plus A3 is equal to A6. And correct. 20 plus 5 is 25. 20 can be gotten by twice of A4. And you can see that twice of A3 is 10. And 2 plus 3 is 5. And 3 is 2 plus 1. So this is a situation where the set A had 9 elements. The set A has 9 elements. So the number of elements of this set can be more than 9 also. But the minimum possible number of elements is 9 because we showed that there is an issue with n is equal to 6. If we had put only 6 numbers here, not 7, then we got the total number of elements of the set was 8. And in that case, we have already shown a contradiction. And what I want you to see is try the cases for lower than 6. If you try the cases for lower than 6, you will realize that there will be contradictions in all situations. And you will not be able to construct this set according to the rules in the problem. So in this case, the number of elements has to be greater than equal to 9. I hope you have understood this problem. Let's look at a final question. Again, a little tricky, but I hope you will understand the aspects of problem solving that we are discussing here. Let's set S be 1, 2, 3, 4. Right? Now we are defining an n-term sequence, of numbers A1, A2 to AN, which has the following property, What is this property? For every non-empty subset of S, let's call that subset something, non-empty subset B of S, there exist mod of B consecutive terms in the sequence that constitute B. So for every non-empty subset B of S, there exist mod B consecutive terms in the sequence, right? So we have to find the minimum value of N. So let's try to understand what this problem is saying actually. So S is equal to 1, 2, 3, 4 is my base set, and an n term sequence has been constructed here, which has the following property for every non-empty subset B of S. What are the possible non-empty subsets? If you think about it, there are basically 16 subsets and there are 15 non-empty subsets here. 15 non-empty subsets, right? For every non-empty subset, let's take a subset B, let's say 1 and 3, right? So there will be two terms. This is my non-empty subset B, and the mod of that non-empty subset is 2, because there are two elements in the subset. So there exist two consecutive terms in the sequence that constitute B. So what does that mean? That means this sequence should have two consecutive terms, 1 and 3 or 3 and 1. 3 and 1 or 1 and 3 should be there in the sequence, and that should make up the full set B, right? The subset B should be there. So let's think of some examples. So what I would say is, I will do it on the next screen. What I would say is, I will make a claim here. Let's each element of S occurs at least twice in the sequence. This is my claim, and I want to prove this claim somehow, right? So let's prove by contradiction. Proof by contradiction. So what we will say is, let's assume X belongs to S and X occurs only once in the sequence. What is the sequence? The sequence is this n-term sequence of numbers, right? Let's assume X belongs to the set S. S set was 1, 2, 3, 4. And X occurs only once in the sequence, right? So let's take, if X is equal to 1, let's take a two-element subset. Let's take a two-element subset B of S containing 1. Right? So if X is 1, I can take two-element subsets like this, 1 and 3. I can also take 1 and 2. And I can also take 1 and 4, right? These are my possible two-element subsets B of S, right? Now, what I'm assuming is that this X is equal to 1 occurs only once in the sequence. So the numbers, other numbers could be anything, but 1 comes here and it doesn't come anywhere else. If 1 comes only once in the sequence, then what are the 2 spots available for consecutive terms? We have 1 spot here and 1 spot here, which are the 2 spots available beside 1, right? So this spot could be filled with 3 or 2 or 4. So we have 2 spots available. So there are only 2 spots beside 1 in the sequence, right? So, and there are 3 numbers, 2, 3, and 4, that can take up these spots, that can take up these spots. So if I put here a 2 and if I put here a 3, then basically what I'm saying is 2 and 1 are part of 2 consecutive terms in the sequence. Similarly, 1 and 3 are 2 consecutive terms in the sequence. So 2 and 1 and 1 and 3 are handled. But what about 1 and 4? Right? So if my subset was 1 and 4, then I don't get 1 and 4 as 2 consecutive terms in the sequence, right? I hope you are trying to understand what I'm doing here. So basically what I'm saying is I have an n term sequence here, right? And I have the set S is equal to 1, 2, 3, 4. The problem says that whenever I take a subset of B, let's take a subset of B 1, 2, right? I should be able to find 2 consecutive terms here which make up the set B, right? So there should be somewhere in the series, there should be a 2, 1 or a 1, 2 somewhere, right? Correct? If that is true, then my condition is satisfied, right? But what I'm showing here right now is that if 1 occurs only once in the sequence, if 1 occurs only once in the sequence, so that means I have a sequence like this, A1, A2, let's say 1 here, and then A4 until AN. If 1 occurs only once in the sequence, then how many possible 2-element subsets I can make? I can make A2, comma 1, and I can make 1, comma A4. These are the only 2 subsets possible, right? But using 1, how many subsets can I make? Actually, I can make 3 subsets, right? 1, 2, 1, 3, 2-element subsets only. 1, 2, 1, 3, and 1, 4, right? So there are 3 elements here, and I have only 2 spots that I can fill. So I can put 2 and 3, but then 1, 4 will be left, right? For this subset, the condition will fail because 1, 4 is not existing in a consecutive term in the sequence then, right? So that means that my claim is wrong. My claim was that there could be an element X of the set S which occurs only once in the sequence, right? That was my claim. But I am showing here a contradiction. When you take B as a 2-element subset, you are getting 3 possible subsets, but you are getting only 2 spots and 2 numbers that you can fill to create 2 consecutive terms, right? I hope you are getting the logic. There is a contradiction here, and therefore what we can say is each element X belongs to S occurs at least twice in the sequence. And what is the sequence? A1, A2 till AN. Each number has to occur at least twice. And S was basically 1, 2, 3, 4. So what I am saying here is that the total number of elements in this sequence must be n must be greater than or equal to 8. Why? Because there are 4 elements here and each element has to occur at least twice. So the number of elements of this has to be greater than or equal to 8. Now, this is still not a construction. We have not really defined our sequence yet. But now I will show you a given sequence, a sequence like this. 3, 1, 2, 3, 4, 1, 2, 4. Let's look at this sequence, right? Notice that each element occurs twice. right? Each element occurs twice. And now, can we think of subsets of this? Let's take a random subset. B, subset of this is, let's take 1, 2, 3. Can you see that there is a 3-element sequence here which constitutes B? Yes. 1, 2, 3 is present. Let's take 1, 2, 4. Notice 1, 2, 4 is present, right? 2, 3, 4. 2, 3, 4 is present, right? 1, 3. 3, 1 is present. 1, 4. 4, 1 is present. 2, 3. 2, 3 is present. So this particular sequence of 8 terms actually satisfies the conditions of the problem, because no matter what subset you pick of 1, 2, 3, 4, you will get some consecutive terms in that sequence. The number of terms will be equal to the number of elements in that subset, which will constitute that subset B, right? How are we getting this? How did we realize that this sequence works and n should be greater than or equal to 8? This sequence I came up with a little bit of trial and error. So you have to construct different sequences and see what works. But the first thing to realize is obviously n should be greater than or equal to 8. You have to make sure that n is greater than or equal to 8. Otherwise, you have a contradiction. If every element of the set S does not occur twice, you will not be able to construct the sequence. If you are still confused, try writing out some different sequences and try looking at the problem statement again, and you will surely get the idea after a little bit of trial and error what is going on. Hopefully you have learned something from these videos and these problems. The problems are a little tricky, and I wanted to expose you to such types of questions. Eventually we'll be tackling many more of these questions in the course. And for now, however, we'll end with the set theory part of the syllabus. We'll move on to the next section of the course, and I will start by discussing quadratic functions. So we'll start the section 2 videos after this, and for now, that's it for set theory. I'll see you next time.